Let us now talk about infix to prefix conversion using stack. This algorithm is going to be similar to infix to postfix conversion using stack. There are few differences though. We are going to traverse the infix expression from right to left here. And first we are going to construct reverse of prefix, right? And you can notice that in the algorithm we have a last step that reverses the prefix that we have built and returns this as a result. So this whole algorithm builds reverse of our result, and at the end we do the reverse to get the original result. Let us now take a look at this algorithm. First we create an empty stack, then we create our result variable prefix. So prefix is mainly going to be reverse of our result. Now we do following for every character. We traverse the given infix expression from right to left and we do this. If the current character is an operand, then we append it to the prefix, like we did in the infix to postfix conversion. If it was a correct operand, we were simply outputting in there. Now, in this case, we are simply appending it to the prefix. If it's a right parenthesis, then we are going to push it to the stack. Right parenthesis means closing bracket. So if it's a closing bracket, a character like this, then we push it to the stack. If it's an opening bracket or left parenthesis, then what we are going to do, we are going to pop everything from the stack and going to append it to the prefix. Please note that we are going to traverse from right to left. So we are going to see a closing bracket or right parenthesis first, then we are going to see a left parenthesis. So the conditions are, if stack st is empty, then we are going to push the current character into the stack. If stack is not empty, then we are going to compare this character c with top of the stack. And then we are going to have three cases. If character c has higher precedence than the top, character c has lower precedence than the top, or character c has same precedence as stack top. So if it has higher precedence, then we are going to push into the stack. If it has lower precedence, then we are going to pop higher precedence items from the stack one by one, and we are going to append the popped characters to the prefix. And once we have popped all the higher precedence operators, we are going to push this character c into the stack. If they have equal precedence, then we are going to use associativity. With some examples, we'll understand how to use the associativity when we have equal precedence on stack top and current character. Now, once we have processed every character of our input, what we are going to do, we are going to pop everything from the stack and append it to the prefix. And at the end, we are going to return reverse of prefix. Let us now understand the algorithm with this example. We have this infix expression. We are going to traverse it from right side. This is an operand, right? Last character is an operand. So when you see an operand, you simply append it to the result. So we simply append z to the result. Next character is an operator. So when we see an operator, we are going to see what is there on the stack top. Stack is empty right now, right? Initially stack is empty. So what are we going to do? We are going to push this operator to the stack. Next character is an operand again. So it's simple. Simply append it to the result. We are going to get zy. Now next character is a plus. So we are again going to take a look at the stack, and this time stack is not empty. So we are going to compare this operator plus with stack top, and this operator has lower precedence than stack top. So what do we do in this case? We take out the stack top and we append it to the prefix. So we take out the star operator and append it to the prefix. And after taking out all higher precedence operators, we append the current character or current operator to the stack. So we are going to append plus to the stack. And after we have processed plus, we come to next thing. Next thing is an operand. So when you see an operand, you are simply going to append it to the result. So this is what we'll get after we process all the characters. But there is a last step. The last step says that if your stack contains items, then pop out everything from the stack and append it to the prefix. So our stack contains a plus operator. So we are going to pop out this plus and append to the result. So this is what we get as a result. But please note that this is reverse of the result. So our last step says that reverse the prefix. So once you reverse it, what are you going to get? You are going to get plus x star yz plus x star yz. This is our final answer. Let us now see the second example. The example is x plus y into z. We are given this infix expression. We need to convert this into prefix. So we traverse from the rightmost character, which is z. It's an operand, so we simply append it to the prefix. Then we see star operator, which is an operator. So we check the stack. Stack is empty, so we are simply going to push it to the stack. Then we see a closing bracket. When we see a closing bracket, we are simply going to push it to the stack. So we are going to push the closing bracket to the stack. Then we see y. Y is an operand, so we are going to append it to the prefix result. Then we see plus. Plus is an operator, and now we are going to check with the top of the stack whether top has higher precedence or this particular plus operator has higher precedence. So top is closing bracket and plus has higher precedence than closing bracket. Closing bracket is bottom priority, bottommost priority. So we are going to push plus into the stack, and our result is going to remain zy. Now once we have processed plus, we are going to come to the next thing, which is an operand. So we'll simply append it to the result. So our result is going to be zyx. And once we have processed x, we are going to see an opening bracket, and the opening bracket rule says that you simply pop out everything from the stack until you see a closing bracket. So we are going to pop out this plus operator and we are going to append it to the result. So our result is going to become zyx plus. Now we have processed all the characters from right to left, from here to here, and our input traversal is done, but there are items left in the stack. So what we do at the end, we pop everything from the stack and append it to the prefix. So there is one character multiplication where we pop it out and append it to the result. So we are having now zyx plus star. Now what are we going to do at the end? We are going to reverse this prefix, right? So our output is going to be star plus xyz. This is our final result, which is prefix equivalent of this given infix. Let us now see the third example. This example demonstrates associativity rule. So we have an expression x power y power z, and this power operator is considered to be right to left associative. So we are going to begin from the last character. It's an operand, so we are going to simply append it to the prefix. The next character is an operator. Stack is empty, so we are simply going to push it. Next character is an operand, so we are going to append it to the prefix. Next character is an operator, and this is where associativity comes into the picture. So if this was a different operator, then we would have compared the precedence, and if stack's operator precedence was higher, then we would have taken it out and appended to the output, and if its precedence was higher, then we would have pushed it into the stack. Here we have same precedence for both the operators. So for more clarity of the explanation, I have numbered these operators. I've numbered this operator as operator 1 and this number as operator 2. This is just for explanation. In our input and output, they are just both same operators. So currently what we have is, we have this operator in the stack and we are now seeing this operator as input. So there are two choices in generally for operators. The two choices are, when this is high precedence operator, we push it into the stack. If it is lower precedence operator, then what we do is we take the stack top out, append it to the result and then push it. And this is what we have done here. We have taken the stack top out, we have taken the operator 1 out, appended it to the result, then pushed it to the result. Now the question arises, why are we considering this operator that came later as a lower precedence operator? Because this operator has right to left associativity. So the operator that came on the right side has higher precedence. That's the simple reason. We don't need to remember the complex rules. We just need to remember precedence rules, right? So this operator has to be pushed once this operator has been taken out of the stack, right? Then we push it to the stack. That's what we have done here. Now we have pushed operator 2 into the stack, and next time we see x, which is an operand. So we are going to append the operand to the result, and we have processed everything from the input expression. So what are we going to do? We are going to take the stack top out and append it to the result. So this was 1. Now we have taken the operator 2 out and appended it to the result. And at the end, we simply do the reverse of this and print it. And reverse of this is going to be this operator, then x, then this operator again, then y and z. Please note that these numberings are just for explanation. They do not have any actual meaning. And this is our final result. This is our final prefix expression for the given infix expression. Here is next example infix expression. Please pause this video and try to follow the steps discussed here and convert this infix into prefix. I am going to talk about the solution now. Here I have converted the infix expression to prefix using naive method. So you can validate your answer whether you got the same answer or not. I am going to next convert it into prefix using the stack based method. So in the naive method, what we do is we first fully parenthesize it. To parenthesize, we use precedence and associativity. These two operators have highest precedence, so we have put them in the innermost brackets. Then plus and minus operator, they have the same precedence but left to right associativity. So we are going to operate on plus first, then we are going to do minus. So once we fully parenthesize, we convert from the innermost brackets to outermost. So we convert this into prefix, then we convert this into prefix, then we convert this plus into prefix. So we get plus x and then this operand. Then we have two operands in the minus operator. So we convert this into prefix. We put the minus operator, then the first operand, then the second operand. So this is what we are going to get the result. Let us now see step by step how the given infix converts into prefix. We'll begin from the last character. It's an operand. So we'll append it to the output. Then we have an operator. We'll push it into the stack. Stack is empty right now. Then we have an operand. We'll append it to the output. Then we have an operator. Now we have something on the top of the stack and we have an operator. So we are going to compare precedence of top and the current operator. Current operator has lower precedence than stack top. So in this case, we take the stack out, stack top item out, append it to the result and then push the current operator. So we are going to take the star out, append it to the result and then push the minus operator, right? Now the next thing is z, which is an operand. So we are simply going to append it to the result. Next thing is an operator. So we check it with the top of the stack and this has higher precedence than top of the stack. So we are going to push it into the stack. So we are going to push this division operator. Next thing y is an operand. So we are going to append it to the result. Now next thing plus is an operator. So we compare it with the stack top. Stack top has higher precedence than this, or in other words, this operator has lower precedence than stack top. So what are we going to do? We are going to take the stack top out and then we are going to append the taken out item to the result. So we are going to append the division operator. Now there is a subtlety here. The thing is, next operator which is on the top of the stack is minus and your current operator is plus. So we need to check the precedence of plus and minus, but they both have same precedence. In case of same precedence, we use associativity. Now we need to decide whether we need to push plus into the stack or we need to take minus out. If minus has higher precedence, then we need to take the minus out. If plus has the higher precedence, then we need to push the plus. Since they both have same precedence, we decide the precedence using associativity. Now if you think for a moment, you can notice that plus should be considered as higher precedence because associativity is left to right. And when associativity is left to right, the operator that appears on the left side should be considered as higher precedence. So that is why we have gone into the case which is for higher precedence case and we are pushing this plus operator into the stack. Next character that we have is x. So in this case, we append x to the result and this was the last character of our input. So what are we going to do now? We are going to pop the items, remaining items from the stack and append to the result. So we are going to take out plus, append it to the result, take out minus, append it to the result. Now the last step is return the reverse of this. So reverse of this is going to be minus plus x and I've written the complete reverse here and this is our final result. You can notice this, that this result matches with what we got from the naive method. Let us now talk about time complexity of this algorithm. We are going to traverse the input infix expression from right to left. For every character, we are going to do these operations. So if our input symbol or character is an operand, then we simply append it to the result, which is a constant time operation. If it's an operator, then we might have to push it to the stack first, and then later we might have to pop it out. So we do two operations at most for an operator. We push it to the stack and then pop out, right? So these two operations are constant operations. So together they are also constant. So we are doing constant work for operators also. So we are doing constant work for the operands, constant work for the operators, and we are traversing through every symbol. So our overall work done is theta n. Then at the end, we are reversing the prefix, which is also a theta n operation. So overall time complexity of this infix to prefix conversion is theta n.